40% of consumers prefer to purchase electronics online. You randomly select 9 consumers. Find the probability that the number of consumers who prefer to purchase electronics online is A, exactly 5, B, more than 5, and C, at most 5. For this problem, we're going to use the binomial distribution. So let's write out that formula. In our problem, N is 9, since we are randomly selecting 9 consumers. P is going to be 0.4 for 40%, and Q is going to be 1 minus 0.4, which is 0.6. Now let's look at part A. Part A is asking for exactly 5. So let's take this and plug in our numbers into our formula. 9, choosing 5, 0.4 to the 5th power, and then 0.6 to the 9 minus 5 power. And 9 minus 5 is 4. Now I'm going to use a calculator to calculate the combination of 9 choose 5, and that's going to give me 126. And now I'm going to plug this all into my calculator as one expression, and I'm going to get the probability. Let me show you how you can do that. Okay, here's my online calculator. So I have 126 times 0.4 to the 5th power times 0.6 to the 4th power. And this is 0.1672. So the probability of choosing exactly 5 is 0.1672. Now let's move on to part B, more than 5. If we want to look for the probability that x is more than 5, we're going to have to calculate individual probabilities for 6, 7, 8, and 9, and then add them up. So we want to find the probability for 6, the probability for 7, the probability for 8, and the probability for 9, and we will add these up. This will be the probability that x is bigger than 5. So let's look at the probability that x is equal to 6. This is 9 choose 6 times 0.4 to the 6th power times 0.6 to the 9 minus 6, or 3rd power. Okay, and I'm going to show you this one calculation, how we can enter it into the calculator all at once, and then I'll just give you the probabilities for 7, 8, and 9. Okay, here's my online calculator again. I'm going to go back and I'm calculating the probability that x is equal to 6. So the first step is to find the combination of 9 choose 6. Then we have times 0.4 to the 6th power times 0.6 to the 3rd power. So I entered that calculation into my calculator all at once, and I find that that probability is 0.0743. Okay, now I'm going to do this with each of my numbers, x equals 7, x equals 8, x equals 9, using that same ability to enter in the entire expression into my calculator all at once. So when I do that, I find probabilities. I'm going to go ahead and rewrite that 0, 7, 4, 3, and then when I find the calculation for x equals 7, I find 0.0212. For 8, it's 0.0035. And then for 9, it's 0.0003. Okay, so I add all these up together, and I get 0.0993. So the probability that x is greater than 5 or more than 5 is 0.0993. And lastly, let's look at part C. Part C is asking for at most 5. So if I were to look at this, this is the probability that x is less than or equal to 5. Now notice that we just got through calculating the probability that x was bigger than 5. So at most 5 would be considered the complement. Remember that the complement is 1 minus the probability that x is bigger than 5. So we have 1 minus our probability that we just found, 0.0993, and this is going to be equal to 0.9007. Now that we've gone through how to use a calculator and hand calculations, I also want to show you how you can use Google Spreadsheets and some of the technology there to find these numbers. So recall in Assignment 2, in Unit 2, we used Google Spreadsheets to do some calculations for the mean, median, mode, and standard deviation. So open up your Google Spreadsheets, and I'm going to just type in our numbers that we're dealing with. So let's look at the probability that x is equal to 5. Okay, so in our problem, we had n was equal to 9, q was equal to 0.6, and p was equal to 0.4. Okay. Now we don't have to have these in our boxes. I'm just putting down the numbers so you can see where we're coming from, or where we're getting our numbers from. So to calculate a binomial distribution probability, you're going to type in equals. Start typing in binomial, or B-I-N. Now you see some options here. You're going to scroll down to the one that says binom distribution, or binomial distribution probability. Use the one that does not contain the dot in it. So click on that. And now as you type it in, notice it'll highlight what you need to enter in. So first you need to enter in the number of successes. The number of successes when we're looking for the probability that x is equal to 5 is 5. That's the number of successes. Now put in a comma. Now you're going to type in the number of trials, and in that's going to be your n, or 9 in this case. The probability of success. The probability of success was p, and p is 0.40, or 0.4. Put in your comma. Now the cumulative, this is asking you, is it adding up all the probabilities before it? And this one, no, because we want to find just x equals 5. So to do that, you would type in false, or F-A-L-S-E. Now you press in the parentheses and then enter. Okay, so you can see that we find here the same probability we found for part A. So if you want to use Google Spreadsheets to calculate these binomial probabilities, this is how you would do it.